Hi everyone, today we're gonna learn how to convert NFA to DFA. We can convert from NFA to DFA, but we cannot convert from DFA to NFA. Implementation of DFA is possible. So if we are to implement an NFA, we first must convert NFA to DFA and then implement it. In conversion from NFA to DFA, if the NFA has n states, then the corresponding DFA will have 2 to the power n states. If NFA has 3 states, which are Q0, Q1, Q2, then the DFA will have 2 to the power 3, which are 8 states, which would be phi or empty state, Q0, Q1, Q2, Q0, Q1, Q1, Q2, Q0, Q2, and also Q0, Q1, Q2. So there are 1, 2, 3, 4, 5, 6, 7, and 8 states. We will not design a DFA for all these states, but only for those states which are reachable from the initial or starting states to get a minimized DFA. All those states in DFA which have final states of the NFA. If Q2 is the final state, every state which has Q2 will be the final state. So this will be a final state, this will also be a final state, this will also be a final state, and this will also be a final state. If we are doing a string acceptance, if any of the path ends on either of these states, we'll say that the string is accepted. Now let's see the process of converting from NFA to DFA. This is the NFA which we must now convert to DFA. While converting from NFA to DFA, we are going to using transition table. It's easier if we have a transition table in the beginning. In this example, we're starting with a transition diagram, so we're going to convert this into a transition table. On transition table, on the top side, we'll be writing all the inputs, which are 0 and 1. On the left side, we'll be writing all the states, which are Q0, Q1, and Q2. On Q0, if the input is 0, will remain on Q0. If the input is 1, we'll go both to Q0 and also to Q1. On Q1, if the input is 0, we'll go to Q2. If the input is 1, we'll go back to Q0. On Q2, which is the final state, hence represented by a circle, we'll represent the initial state with a small arrow pointing. On Q2, if the input is 0, will remain on Q2, and if the input is 1, will also remain on Q2. Now this is the transition table for NFA. Now we're going to construct a transition table, but for DFA. The first thing we do is we start from the initial state. So Q0, the inputs will remain the same, 0 and 1. It will be the initial state. On Q0, if the input is 0, we'll reach Q0. So Q0, and on Q0, if the input is 1, we'll go to Q0 and Q1. In this line, only Q0 and Q1 which does not have its own row in the table. Q0 already has its row, so we'll write Q0, Q1 as a single entity, and now Q0, Q1 on 0 goes to Q0 goes on 0 goes to Q0, and Q1 on 0 goes to Q2. So we'll write both of them as single entity, Q0, Q2. Q0, Q1 on 1 goes to Q0 goes to Q0, Q1, and Q1 goes to Q0. So Q0, Q0, Q1. Since it is a set, we don't have to repeat it twice. We'll just write Q0, Q1. Now Q0, Q1 has its row in the table, but Q0, Q2 does not. So Q0, Q2 will make another row for Q0, Q2. Q0, Q2 on 0 will go to Q0 and Q2, and Q0, Q2 on 1 will go to Q0, Q1 and Q2. Q0, Q2 has its row, but Q0, Q1, Q2 does not. So we'll make another row for it. This Q0, Q1, Q2. On 0, it goes to Q0, Q2, Q2. So Q0, Q2. On 1, Q0, Q1, Q2 goes to Q0, Q1, Q0, Q2. So Q0, Q1 and Q2. Now Q0, Q2 has its row, and Q0, Q1, Q2 also has its row. So we've reached all the states. There is no new state, and when there's no new state, at that time we'll stop. In the initial NFA, Q2 was the final state. Here, every state which contains Q2 will be the final state. So this will be the final state, and this will also be a final state. We can draw a DFA from this table where we consider these as single entities. So this will be one state, this will be one state. The deterministic finite automata constructed from this table will look like this. This is the NFA that we started with, and this is the DFA that we converted it to. The initial state Q0 will remain same in both DFA and NFA. The final state is Q2, and the final state in DFA would be the every state which contains Q2. So this contains Q2 and this contains Q2. So both of these are final states. Since there were 3 states in NFA, the DFA can contain 2 to the power 3 or 8 states, but out of those 8 states, only 4 are reachable, so we won't draw other 4 states. This is a minimized DFA.